Okay, so now that we've really entered the realm of statistics, I want to talk a little bit about regressions. So we've run this regression and it's drawn the best line. Here's the results. All right, how do we read that? Well, a couple of key areas, and we're going to talk about them more, but we've drawn this line and it's telling me this is describing the line. All right, this describes the line that we drew. And it's giving me some goodness of fit measures, which we'll talk about later, but I'm looking at my R-square, it's pretty high. I'm looking at my t-test, it's looking good. So I'm saying, so we'll get to goodness of fit in a little bit, but how do I know this is a very good line? Because my goodness of fit, the fit of the line, is pretty good according to these measures. All right, so what is my line? Well, here you go. There's my intercept, 854, and there's my there's my slope, right? The x variable. All right, so this is my line. This is how I know my line. All right, so that's how you interpret that. So here's our equation. Y equals 12.39, that's slope, times 350, or whatever number you want, the 350 output, plus 854.50, which is your intercept. So you can fill any number you want in here and come up with total cost. So the total cost for 350 units is $43.36.50. That is composed of $12.39 variable cost, $854.50 fixed cost. Right, so that's what we're doing. We're estimating the line, and there you go. So now that I know this formula, I can estimate my total cost for any output I want to do. If I want to make 500, if I want to make 1,000, whatever number I want, I just plug in there times 1239 and add 854, and I will get my new Y total cost. All right, so how do I know this is any good? All right, well, that's one thing I want you to understand, not how to calculate, but just go, okay, did I draw a good line using my regression analysis? Is it very good, or should I look for more variables? Because maybe you think material moves is the best variable, but maybe it's machine hours, right? So go, oh, is that good or is that bad? Well, we have some what we call goodness of fit tests, and we'll talk about that. So this is how I know I have a good line or not. Typically, we'll take this test, so we can test how close our estimate is to 0 and come up with a p-value. So if you look at a readout, you'll see a p-value and it'll have numbers, 0.0001 or 0.01, you know, it'll have numbers. This one, there you go, 0.00001. So that's really good. The lower it is, the better it is. So we know that our slope is a pretty good number for that variable. All right, that's all that means. So p-value tells you if you're pretty. If you have well, it's have you achieved significance? Is that a significant result? And so that's good. You want to know that. Goodness of fit, R square. R square is a percentage, so you'll see something like 0.8, 0.9, right, like 90%. So the higher that number, the better. So if we come back here to this output, and you'll see this right here, R square, 0.86, that is pretty good. I mean, that is telling you we have explained 86% of the variance in the costs. That's what that means. So we understand 86% of what drives that cost for whatever that is. All right. So 86% is good. It's not perfect. We don't know exact, but again, these are estimates anyway. I mean, right? There's going to be a lot of variation in costs. Right? You got humans involved. You got price fluctuations. You've got people sometimes waste some material. Right? You can't build everything perfectly. So, you know, you can't perfectly explain the costs, but 86% I would say is pretty good. All right, so goodness of fit, using R squared is good. Adjusted R squared just means it's been adjusted for the number of variables, or what we call degrees of freedom. We'll get to that in a minute too. All right, so the next way we can tell if we did a good job is look at the coefficient of determination and what we call the correlation coefficient. If you have a correlation coefficient of 1, there's a perfect correlation. If you have a -1, there's a perfect negative correlation. Most are going to be somewhere in the middle. If there's 0, it means they're not correlated. So here's a little picture. So if you were to see machine hours and utilities costs, so the more I run the machine, the more I use electricity. It's perfectly correlated. If I turn the machine off, I use 0. I keep it running, I use more and more and more. So that would have a correlation coefficient of 1. All right? Some things are negatively correlated, right? So in this example, they say, hours of safety training. As I train my people more to be safe, accidents go down. Negative correlation. So a perfect negative correlation would be -1. All right. And some things are not correlated at all. Hair length and accounting grade. So there you would see a 0 correlation of coefficient. So if you see something approaching 1 or -1, you've got either a really good correlation, positive or negative. If you see something near 0, it's like, oh, these aren't very correlated. So it's not a good choice for way to measure costs. Confidence intervals. All right, so confidence intervals, you won't have to calculate. There's a table in there, but all I would want you to really understand about confidence intervals is that you are kind of establishing what I would call a probability. It is a probability. It is 95% probable that this is the right cost. All right, so that's what a confidence interval is, and I just expect you to be able to understand what that is, not ever calculate one. All right, so the next thing we're going to talk about is finally an additional quantitative method, multiple regression. Again, you won't have to calculate it, but I want you to understand what it is.